from here. And while we switch over, Dan, do you want to switch over? While we switch over, let me just quickly introduce the two speakers. So the two speakers, Carsten Czarski and Dan Geringer. Carsten is an Oracle colleague of mine from southern Germany, so very different from up here in northern Germany. Carsten was looking after the spatial technologies in the German market when he was still in pre-sales, and back then he actually worked together quite closely with the Spatial SIG of DOAG, the German Oracle user group. He has since then defected and joined the Oracle Apex development team, where he's focusing on the REST-related features, the calendar, a couple of other things. But he still has an affection for the spatial technologies. I think he is, by the way, the one who has built the Apex geolocation showcase. If you have been working with Apex, you may have come across that. He is presenting together with Dan Geringer from the spatial development team, so from our team. If you don't know Dan, Dan is our specialist on anything to do with scalability, performance, security, high availability, all of that. And he's spending a lot of time on projects with our largest customers, our key partners, and he has gathered an enormous amount of experience over the years, and regularly, and that's the nice thing, he regularly shares that at user conferences such as the Analytics and Data Summit or the TechCast days like here. And Dan, by the way, is also the brain behind the contact tracing functionality, which he'll tell you about. So Dan and Carsten, over to you.
All right, thank you, Hans. My name is Dan Geringer. I'm part of the Oracle Spatial and Graph Development team, and I'll be presenting the Oracle Contact Tracing portion of the session today. So the session will kind of be in two parts. I'll present first these new Oracle Contact Tracing SQL APIs, and the second part of the presentation will be by Carsten, who will actually show you how to build an Apex application using the contact tracing SQL APIs, as well as just general spatial with Apex. So Oracle Contact Tracing SQL APIs, these are very new. So these are just available recently, free, automatic, and scalable. They're included in every Oracle database edition with Oracle Spatial and Graph. So beginning in December of 2019, Oracle Spatial and Graph is now available at no cost in every Oracle database edition. And now these two new features, these two new APIs, Oracle Contact Tracing, are also available in every Oracle database edition. This is just a little slide overview of Oracle Spatial and Graph. As I said, included in every Oracle database edition at no extra cost. And it's lots of functionality. You can store spatial data points, lines, polygons. You do location tracking, network analysis, geocoding, linear referencing, topologies, LiDAR data, 3D LiDAR data. We can store raster data. We've got deployable components for mapping, for geocoding, for routing. So these are web services, as well as something new called Spatial Studio, which makes it easy to basically abstracts you from writing the SQL for the spatial analysis. Very easy to use interface. And what's new here is the very one at the bottom that I kind of skipped over, contact tracing. So this is now part of Oracle Spatial and Graph, and that's what I'll be going over today, is the new contact tracing APIs. So there's two new contact tracing APIs. I'll be talking about both of them. So you have API number 1 requires no GPS tracking data, and API 2 requires GPS tracking data. So there are two different APIs. I'll discuss each one separately. API 1, I call it the swipe in out contact tracing. So for examples, you could have sensors on buildings or floors or rooms. Lots of buildings already have these types of sensors. The sensors record badge swipes in, out, and a badge swipe, when you swipe your badge, basically records a timestamp and whether you're going in a room or out of a room. The API automatically will do analysis on all of these swipes and report users that share the same room. And the API also reports how long people were together in rooms. Right? So this is no GPS tracking data. It's based all on time overlap analysis. There's a second API that I'll go into more detail as well, which requires GPS tracking data. It's proximity and time-based contact tracing. So if you have tracks of data that are being collected for users by GPS sensors over time, what this API does is it compares an input user GPS track to other GPS tracks. The API will report all the GPS tracks that coincide both in proximity and time with the user's GPS track. And it will also report how long the tracks coincide both in proximity and time. Excuse me. So we'll start with the first API, the swipe in out contact tracing API. So what is it? Like I said a second ago, right? Find all the people that share the same room at the same time and report a metric like duration. Excuse me. Duration is a very, Duration is a very important metric. How long did people share that space? For example, sensors on buildings and rooms. A college, for example, might install sensors on classrooms. Or a company installs sensors on floors, conference rooms, and offices. Or a nursing home might install sensors on bedrooms, activity rooms, and dining areas, right? And the key is swiping in and out when you enter and exit these rooms. So then you can do analysis on this later, time overlap analysis, to see what users shared space and for how long, right? The API automatically will identify anyone that shared a room with someone positive, for example, and report how long they shared that space, the duration. What do you do with that? Once you know someone has been, basically exposed, you might want to quickly notify anyone that was exposed to possibly quarantine. So the data model is extremely simple. So this would be an Oracle table. It would have basically 4 required columns and 2 optional columns. So very simple. The user ID would be the first column. You'd have the swipe time, an Oracle date format is the second column. Another column that tells you whether you're going in or out of a room. And a building ID would be a required column. What building are they entering or exiting? Then you have some optional columns, a floor ID and a room ID. So you can see I've got some sample data here loaded. So I have sample data for user ID number 1, user ID number 2, user ID number 3, each of them going in and out of a room. So building 1, room 1, you can see I optionally skipped floor, and the API will work on any permutation of, well, building ID is required, or building ID and room ID, building ID, floor ID, room ID. So in this example, on February 28th, 2020, at 1 p.m., user ID 1 swiped in to building 1, room 1. At 2 p.m., they swiped out. And you have user number 2 that swiped into the same room in the same building, but prior to user 1. So they swiped in at 12 p.m., right? User 1 swiped in at 1 p.m. So they swiped in before, and then they swiped in halfway through the time that user 1 was in the room. So at 1:30, user 2 left that room. User 3 entered that same room prior to user 1, so at 12 p.m., and exited after at 3 p.m. Right? User 1 exited it at 2 p.m. So you have many different types of permutations of when people entered and exited rooms to try to figure out this time overlap. What we've done is provided a very simple SQL API that if you populate a very simple table like this, you can run the API and it'll report time overlap, users overlap, and duration. Let's look at the SQL API. So it's got several parameters, but in the gray box, I highlighted the parameters that all they are table name and column names. So you specify for your table that I showed you on the previous slide, the name of your table, the user ID column name, the building ID column name. So all this is kind of like set up for the API to dynamically build SQL against your table. But to drive the actual analysis, it's really these three parameters that drive the analysis, the first three. What user ID do you want to perform a trace on? So user ID 1, for example, I want to find all of the users that shared a room with user ID 1. And I want to perform my trace from some start time to some end time. So maybe I want to do it over a day, or maybe I want to find out anyone that shared a room with that user over 3 days or a week, etc. So these three parameters, the first three parameters, really drive what analysis you're going to be doing. So these APIs can be easily installed by downloading a patch. We've made them available through a patch mechanism on support.oracle.com. If you download this patch, it doesn't require any downtime at all to load the patch, and it works on versions 18C and 19C. I've been recently asked if it's available on 12C, and it's something that I am investigating. So I will show you a quick demo in SQL Developer. So here's a SQL Developer, Oracle's interface for writing SQL and issuing SQL statements. And you can see that basically this API, when I run it, it will generate a report, a very useful report, reporting all the users that that shared rooms and their duration. So here's my drop and create table statement for that table, where the sensor data is going to get populated into my user ID, building ID, floor ID, my swipe in out and time columns. And then I will populate. This is exactly the data that I showed you earlier. So I have user ID. Actually, I added one more. I have user ID entering and exiting room 1 at 1 p.m., entering and exiting it at 2. And then I have that same user ID number 1 entering room 2 at 4 p.m. and exiting room 2 at 5 p.m. And then I have other users that basically are entering, exiting rooms. So insert all that data into the table. And now for running the API. Like I said, the first three parameters are the ones that really matter. These are the ones that drive the analysis, right? So you have user ID 1 is the one I wanted to trace. Now I'm going to trace that user from February 28th, 2020. I'm going to do a trace from 8 a.m. in the morning to 8 p.m. in the evening. The rest of the parameters to the API are just the table name and column name parameters. So there is one condition in the where clause. So I have segment are all equal to segment. And when I get to the next version of this API, which is going to be the proximity version that does use tracking data, you'll see that this template is very similar. So we have this parameter here, this predicate segment or all, and I'm setting it equal to segment. When I do that, it'll report by room which users interacted with user 1. And I'll have another way, and I'll show you a second query in a second, where I'll say segment are all equal to all, where it summarizes all of the rooms that had contact, that users had contact with user 1. So let's just run this first one. And the results are right here. So basically user 1 had shared a room with user 2. User 1 again shared a room with user 2, and user 1 shared a room with user 3. Here's the building ID, the room ID. It'll report the start time and end time. So user 2 shared a room with user 1 from 1 p.m. to 1:30 p.m. and the duration being 30 minutes. Later on in the day, in room 2, that same user 2 shared from 4:20 to 4:40, a 20-minute overlap with user 1. So user 2 is listed here 2 times. It had 2 interactions. And then user 3 had a single interaction for 60 minutes on room 1. Remember, I don't know if you remember, but basically user 3 entered that room prior and exited the room after user 1. So here's the same exact SQL statement. The only difference I'm going to do is I'm going to say segments are all equal to all. So it's doing the same exact analysis, and what it's going to do when I run it, it's going to summarize these two, which had a 30-minute duration and a 20-minute duration for user 2, and it'll summarize it into a single row. So I want to find out kind of a summary analysis for each user, how long they interacted. So 30 plus 20 is a 50-minute duration throughout the day. So it starts from 1 p.m. to 4:40 p.m. There was a 50-minute overlap in time, and it also can report how many contacts. So earlier I showed you that there were 2 times in that day that there were contacts. Here it reports how many times that the users shared rooms and the total amount of time. Duration is key, right? And we all know that that's been reported by experts in the field. The amount of time that you're exposed to somebody is a very critical factor. And that's what this API basically does. So with that, I'm going to actually go back to the presentation. And we're going to talk a little bit about the second type of contact tracing, which is proximity and time-based contact tracing.
Dan, before you move on to that, maybe it's a good opportunity for a question which we had on the chat, which touches on the swipe in, swipe out infrastructure. The question was how to distinguish in and out events, and maybe also how to figure out who's exiting a room and the like. Do you want to briefly comment on that?
Sure, absolutely. So basically that would be up to the sensor that's collecting the data. So basically the sensors on the rooms when you're going to enter, when you swipe your badge or whatever mechanism it has to record the time, it would also record whether the person was entering or exiting the room. So that data that's being collected by the sensor just gets input into an Oracle table. So that is just the mechanism of transferring the data from the sensor to the Oracle table. Once it's in the Oracle table, running the API and detecting the time overlap is all automatic.
Yes, thank you.
Yeah. So what is proximity and time-based contact tracing? So this is a little different in that this works on GPS tracks. This truly works on GPS positions being reported as you're moving along, right? So find people that share space at the same time. And also report metrics like duration. For example, a hospital or a company can ask employees to opt into collecting their position while at work. So collecting their GPS position as they move. It could be, and the rate of collection is up to the collection sensor. So it could be collecting it, every 30 seconds or every minute, so that's all up to how often you want to collect that position of that person. If someone calls in sick, identify all the employees that were within 6 feet of a sick person over the last week, and how long were they in contact with that person? In other words, the duration. As I mentioned earlier, duration is a key reporting metric. Example 2, so this API is not really limited to just COVID type analysis, right? So this could be used for any kind of overlap, any type of GPS track overlap analysis. For example, ship tracks. You might have sensors on ships that collect GPS tracks over time. You might want to ask a question, find all the ships that shared the same space at the same time, and how long did they share that space? How long were they close to each other, right? So this will work on any tracking data. So tracking data collects position and time of moving objects, and this can detect given a certain distance within the 2 tracks, so the proximity and time-based contact tracing can be performed on any track data. So let's look at some examples of how this API works. So on the left side, if you were just considering proximity, I have 2 tracks. I've got the blue track on the bottom and the black track on the top. And these 2 positions are within a certain distance of each other, so we'll call it a match. These two are within a certain distance of each other, let's call it a match. Same here, here, and here they start to diverge, so they basically are no longer within a certain distance of each other, there's no match. On the right side, I've got the same exact points, but what I've done is I've assigned a timestamp to each point. So this one and these two are basically 9 minutes apart. So even though they are within a certain required distance, they're not a match because their timestamps are too far apart. 9 minutes apart is too far apart. So these two also are 9 minutes apart, so no match. So here you have no match, no match, no match all the way through. So the key for this type of proximity and time-based contact tracing is for both proximity and time matching. So it's correlating both proximity and time. So here's another example. So in blue, you have user ID 2, so track number 2. And in red, in black above, you've got another track for user ID 11. So these two look like two good candidates to perform, to say that they might match, right? Proximity-wise, yes. But then if you look at the times on two tracks, since they're being collected by different sensors, will almost never match exactly. So you need some kind of, a little bit of a configurable time window. So here you have 2 points that are within a certain distance, right? That are an acceptable distance to be considered a match, but their times are 30 seconds, a little within 30 seconds apart, so 28 seconds apart. So this basically is a time tolerance saying allow points to match even if they're up to 30 seconds apart. And you get to define what that interval, that time interval is. Generally, it should be a function of the collection rate of the data. So if my data is being collected at every 30 seconds, I might make my time tolerance something like 60 seconds, right? If my data is being collected at every second, I might make my time tolerance something between 3 and 5 seconds. So the time window should be a function of the collection rate of your data. So now we have 2 points here. They're within 30 seconds of each other and within proximity. So these two would be considered a match. These two are considered a match. These two as well. These two as well. These two also considered a match. And then the 2 users start going their own way and there's no more matches. So now we want to also start accumulating something called duration. So reporting the duration of how long these users were in proximity of each other. So here we have user ID 2 on the bottom and its track, and user ID 11 on the top and their track. You have these two points matched. Then each of the users went their own way and they came back together. So they had matches at around 1 p.m. And then later on in the day, so they went their own way. And later on in the evening at 8 p.m. or at 10 p.m., they started matching again, right? So you have matches at 1 p.m. and you have matches at 10 p.m. So to start computing what's called duration, you need to have at least 2 consecutive points in what I call a chain to compute duration, because you have to subtract the time of one point from the other point. Well, as you're doing that, look at these 2 points. So they met each other at 1 p.m. and then there's these points down here, and then they met again at 10 p.m. I don't want to basically subtract the values of these 2 points because that would add a large amount of false duration between points. But basically, we need a break here, and it's going to create 2 different chains here, and it's once again a configurable parameter. How far in time do points have to be, or how close in time do they have to be considered as part of a chain? So you can set it something like 60 seconds. These 2 points are consecutive. They were both matches, and they were both within 60 seconds. So start accumulating duration. Accumulate duration here, here, and here. The next match point is 9 hours away. Way more than 60 seconds. don't accumulate that as a duration. So I have two different chains, one which accumulated a 2 minute and 40-second duration, another one which accumulated a 1 minute and 48-second duration. You also have the option, like I kind of showed you earlier with the time-based contact tracing, to summarize all of the contacts. So I can report this, and you'll see in a minute through the API, I can report this as two separate instances of interaction, of matches, or I can actually combine them as a summary row in a single row and just say that there was 4 minutes and 28 seconds and there were two different contacts, one at 1 p.m. and one at 10 p.m. The data model for this is also very simple. So this is where the tracking data actually gets put in. You've got your user ID, your capture time for your GPS point, the actual location, the geometry, the longitude, latitude for the point. And then you have some optional columns. So one is called data's number, and that's for an optimization, and I'll explain that in a minute. And an accuracy. For example, if the data is being collected and it has some accuracy associated with it, you may want to either include it or exclude it. So if the point of a particular row has a value of an accuracy of 0 means that it's super accurate. 3 means it's accurate to plus or 3 meters. And a 45 would mean that it's accurate to plus or minus 45 meters. Well, that's very inaccurate. Maybe I want to exclude this. So I can actually specify the accuracy in this table. And when I call the API, I'll have a mechanism to basically eliminate anything beyond a certain accuracy. So some optimizations. Leverage native Oracle spatial indexing. So this is how you create an Oracle spatial index, since proximity is certainly a key factor of this type of analysis. Create ordinary indexes. Use Oracle table partitioning. When your tables get very large, you can partition your tables by time. And there's other key scalable features of the database that you can leverage, something called attribute clustering, which is a way to optimize the way data is stored. And this really helped performance. So basically using attribute clustering on time, longitude, and latitude. So there's another optimization that I incorporated into the API, and it's, Oracle has a really neat thing to be able to do data arithmetic. For example, if you have two dates, January 1st of 2020 and January 1st of 2019, I can subtract those and it returns the answer in days, so 365 days. So this type of API does quite a bit of time analysis, so time arithmetic. So what I noticed is that time arithmetic, when you're doing it repetitively, is a little bit slower than just doing number arithmetic. So I see number arithmetic being at least 2x, sometimes 3x faster than data arithmetic. So there's an optimization to be able to store your time in an additional column called data's number. And all it is picking some reference date. You can pick any date as your reference date that's prior to all your data. So if all my data is from 2020, I might pick January 1st of 2019, sometime that was before all of my dates, and basically create a time that's basically your time minus that reference date. So you're not normalizing the date in this data's number column to some reference point. Now I have all my dates stored as a number, and I can do numeric arithmetic instead of data arithmetic. The SQL API is very similar. Most of the columns here highlighted in gray are table name and column names. The key parameters being that you would specify to do an analysis would be the user ID that you want to trace, the start and end time you want your trace to occur at, how far of a distance can a point be, so for example 15 meters or 6 feet, right? And then you have your time tolerance and chaining tolerance, which I explained earlier, and here's the accuracy filter that we talked about earlier as well. So I have two quick demos before I hand it over to Carsten to show you the Apex side. First thing I'm going to do is show you a SQL developer. demo as well. Here, once again, these are all just configuration, the name of my table and my geometry column, etc. But what am I doing? I'm doing a trace on user ID number 23, and I want to trace that user from April 26th at 12 p.m. to April 28th at 11 a.m. So it's a pretty much a two-day trace of that user, and show me any tracks that interacted with that user. I'm going to use an accuracy filter of 8. In other words, anything with a accuracy greater than, plus or minus 8 meters, anything that's less accurate than that will get excluded. If I run the query, basically it reported the answer. It told me that so user ID 23 is my input user, and it interacted with an output user 34 and an output user 35. 34 actually, how many times? Remember I just showed you earlier that there was an interaction at 1 p.m. and the one at 10 p.m. So this user 34 interacted 13 times in that 2-day period. I could click on here and actually see the geometry, the actual locations. So it's correlating both time and space, right? And it tells you the start and end time for those. And then there's another user, and it tells you the duration is 5 minutes. So there's a 5-minute duration for contact for each of those. If you want to see the individual contacts, so the 13 different contacts for that user, you can run the same query, except at the bottom you can see I'm going to say segment or all equal to segment. If I run that query, it's going to show me for user 34 each of the segments. So if this was a 1-minute interaction, 0 minutes, 0 duration means that it was a single point, right? You need at least 2 points to compute a duration. So if it was a single point, it just reports the point, but the time, the start and end time will be the exact same. Then you have a 1-minute duration. So basically this is showing the individual, it's showing you the individual interactions. I'm going to go back. I'm going to show you one more quick demo. This is another.
Dan, I'm a bit conscious of time, so that we leave a little bit of time still for Carsten.
Okay. I'll be done in 2 minutes. This is my last demo. This is another small demo that shows the same kind of GPS interaction, GPS contact tracing results. So here I have, basically, I'm highlighting here a chain that interacted for 63 minutes. So user ID 7 was my input user, and it's saying user ID 6 basically interacted for a total of 65 minutes. And I can do the same thing to basically, there were some other basically interactions here. So here's a 5-minute interaction. So we have different chains, and I can say segment or all equal to all, submit the query again. And basically what it'll do, instead of separate, so there's the contact tracing is done, and now it just creates a single interface, a single interaction that summarizes 16 contacts for 93 minutes. And here's the tabular output as well. With that, let me just go back here. The key here being 2 new contact tracing SQL APIs, free, included in every Oracle database edition, automatically identifies contacts and reports duration, and scalable, leverages Oracle native database partitioning, parallel query, attribute clustering, spatial indexing, and more. And with that, I'm going to like to hand it over to Carsten, who's going to actually show you how to integrate this within an Apex application.
Yeah, thank you very much, Dan. And let me now, in the remaining few minutes, show you how Apex can be used to visualize the results of such contact tracing calls, or as we will see, even other functionality which is part of the Oracle database. And since this is not Apex typical event, maybe quite a few of you don't know what Apex is. So let me, in less than a minute, quickly characterize Apex for you. So Apex is Oracle, it's a low-code development tool. It allows you, as low-code tool do, to build database-centric applications with less code and basically by declaring things and adding code only in those places where really needed. The key thing about Apex is that, as you can see here, it runs inside of the Oracle database. So every part of your Apex application will be processed inside the Oracle database. There is a web server in front of your database, which is ORTS in our case, and then on the left-hand side, we have the browser. And when we now think about what we've seen from Dan, then Apex is a perfect fit because the contact tracing APIs, all the work is done in the database. So when it's about bringing the results of this to the browser, to an application, a low-code tool which runs in the database might be a very good fit. And how this could look like is what I'm going to show you now. I already logged into my Apex workspace. And when you log into Apex, let me also quickly touch on that. You start in the home screen, and then there is the application builder where we build applications. We have SQL Workshop, which is sort of a SQL interface in the browser. And let's touch base on what we've seen from Dan. And let me run the same swipe-based contact tracing query in Apex SQL Workshop. And here we see the same results again, right? The data is a bit different. I've seen Dan's data was from February this year. This is all January the 1st, but the concepts are exactly the same. We are calling the contact tracing API, and this is a simple query executor. So we just see that here. That's not an application. So how can we build an application based on that? With Apex. So let's then go to Application Builder. And I already created a more or less empty application and an empty page, all right? So let me run this empty page and we will see a boring page, nothing on it. That's right, there is nothing on this page. So the first thing we might want to do is visualize that data from that contact tracing query in a tabular form, not actually the same thing we just did in the SQL, in the query executor, but now as part of an application where end users can, for end users, right? So that's the most simple thing. I'm just copying the query into, into the classic report, contact tracing. And let's now run this. Okay, we now have an application, that is the same output as before. The boring thing is still we can't pick a user, so let's change that as well. So let me add a select list, right? Let's get some interactivity here, and that is the user ID, and that should be a select list. And if we want to work with a select list, we need a data source. So I have prepared a track users table where we can see all the user. And so my list of values for my select list will now be driven from that SQL query. Let me, when I did a selection, let me redirect and set value. And let's see what we now have. We have a user ID select list. And so if I change that, the page is reloaded, but nothing happened in the report so far. Okay, still some work to do. Let me now replace the hard-coded user ID here by our new select list item, right? That's correct. And then we want to get rid of that annoying warning message. So let's remove that as well. So, and now we have a very basic interactivity, right? Just in 2 minutes, quickly put together, we can now have a select list for the users, and the report always shows us contact traces for that user. So of course, we can invest a bit more of time into our application, and Apex can do more than just tabular reports, right? When we look into the component palette, so we have calendars, we have charts, the classic report, we've already seen that. We have faceted search, forms. Now, forms are not that interesting here. interactive reports where end users can filter a bit on the data, and other stuff as well. So on page 1, I prepared a bit more. And here I used a chart, right? And for such contact tracing, this data actually is a nice fit for a Gantt chart visualization. So if we now have, and that's the same query, right? Now with a few more UI elements on the page, again, we can switch the user and we see a classic report, which just shows the data. And that start time to end time and duration actually is a very nice fit for that Gantt type visualization, right? The different room are different colors. So we can now see user 1 has traces to user 2, and that was for this 15 minutes in building 1 and for another hour in building 2, right? And so we can now see not only the data, we can also see a visual representation of that, and this is much more compelling, and you get a way better impression on the data than just watching the relational tabular output. User 7, as we can see, has not too much interaction, and that really gives you a very nice UI on top of this. All this is done in Apex by putting these standard components together. And the Gantt chart, again, has a SQL query as the data source. You can really see how Apex is tied to the database. And once you have a SQL interface to functionality, and the contact tracing is an example for having some powerful functionality with a SQL interface. And as soon as we have such a SQL interface, we can leverage all these Apex standard components and start building our applications out of this. And this is, as we have seen, a chart, a Gantt chart. And this is, again, the classic report we have seen before. And what we also have is a bit more the select list again, and start and end date pickers we have been used to determine the tracing, duration, the start and end of the tracing area which we want to have a look on, right? So, and like this, you can visualize and build your UI on any other data feed which is accessible by SQL. From the Apex point of view, there is no difference between a Gantt chart on a plain table with some project data and a Gantt chart on this contact tracing. The key thing is the engine, but what's really nice about the built into like Apex is that we are in the database. But this is relational data. Dan also showed the coordinate contact tracing, which is based on geometries. And let me also, in the remaining few minutes, give you an impression how that could look like. I need to switch environments for this. So that's just another Apex instance. And let me first quickly show how the contact tracing based on spatial data looks like in an Apex application, right? Again, we have a select list for user IDs. We have start and end timestamps, and this even has a bit more, right? We have a tolerance knob here where we can say, oh, how accurate should the contact tracing work? So, and it's again the same thing. We can switch the user ID, pick a start and an end timestamp, and here this is a map region type which plots the geometry data on a map. So the spatial contact tracing API returns geometry data, among other data, of course. And here it's not a classic report and also not a Gantt chart. We are using a different component. But once we look at how this component looks like in Page Designer, then we can see it's again the Apex principle, which is in action here. So we have the map component, and again, the source of the map component, a SQL query again, right? And that's how all the Apex components work. And to give you a bit better experience how to build a map on contact tracing or a table with spatial data, I would like to take a few minutes to walk you through, let's say, maps in Apex 101, right? And this starts with an empty application, right? So I can log in here again. No, it's admin. And again, this page is empty. And the first thing is we need a map, right? So let's open Page Designer and let's have a look. There is a map chart, but that's not what we want to use. We want to have a real map to use with coordinates. That's something which Apex has not named. So there is no component for this in this palette here. However, we have something, right? And together with Apex, we deliver a set of pre-built applications for you. And one of these applications is the Sample Geolocation Showcase. This is a generic showcase which shows how to work with spatial data and Apex. And this Sample Geolocation Showcase also contains a map component. And in Apex, we talk about plugins in that case, right? Apex has an extensible architecture and you can build your own component types. So the Sample Geolocation Showcase is already installed. And now I want to use the map component in this application. So let's go to Shared Components and the plugin area. No plugin there right now. So let me create a new one. Let me copy it from an existing plugin. And let's use next. So let me copy that from the Sample Geolocation Showcase. And yes, I would like to have all of these. That makes it more easy. So simply copy the plugins over to my application. So that's something we can now work with. And now when I open Page Designer again, we have our Oracle HTML5 Maps region plugin. And that's the plugin which is based on Oracle Maps. So we are now all set, except the table. What data should we use to work with? So let's go to the SQL command thing again. And I have prepared a table, which I hope is more or less familiar to you. No, it's not earthquake data, it's earthquake table, of course. So, and here I have earthquake data from the USGS site. And as in the real life, right, we don't have geometries, we have two number columns, latitude and longitude. So I want to have a map based on these. And I should be able to build this in less than 5 minutes. So let's get started. First, we want to have the geometry column, right? No, come on. So we just have two number columns, but no real spatial geometry columns. So let me add that column. Okay. Then let me update the table so that the latitude, longitude columns are copied over to our geometry column. Done. All right. Next thing is we want to have a spatial index, right? This is the Oracle Spatial 101. You first need to create metadata for your spatial table, then you need to create the index, right? So let's first create the metadata, and then let's create the index. And I think in a few seconds, we are there. Here's our index. So the table is prepared. We have the plugin in our application. So let's now build actually our application. And I would like to drag the map region. And again, we want to have a SQL query. What SQL query? Apex provides help. Right, here is a help text for that plugin. And here is also a sample query. I think we should be able to work with this. Let me have a look into so we have the ID, we have the title, info tip, we have the geometry, and let's go with the MAC. Then we want to have a red marker. When MAC between 2 and 4, we want to have a yellow marker. And else we want to have a green marker. And then I think we only want to have earthquakes with a magnitude of 1 or higher. From
Carsten, I hate to interrupt you, but we need a few moments for the poor guys who are presenting after you to switch over. So do you think you can
let me just
play the map?
Let me
And
just
then
because
and then
I should be already in time.
Perfect.
And here are our earthquakes. Right? In a few minutes, we have the spatial. So we have spatial data in an Apex application, and of course, you can add the other components I talked about to build a real application out of this. That actually concludes my demo. Thanks for the attention, and I head back to Hans.
Okay, brilliant. Carsten, thank you so much. My suggestion to everybody here is, if you are interested in a dedicated session on using spatial data in Apex, creating maps in Apex, using the geolocation showcase in Apex, and so forth, do drop us a note in the A&D OUC Slack channel, right, in the A&D OUC Slack workspace. That would certainly be something we'd be very happy to organize and very happy to arrange. It's one of the things where you can, mention what you're interested in next steps, things you would like to see as presentations, as webcasts, as whatever. So thank you very much, Carsten, for the demo. Thanks to Dan also for the introduction to all of the new APIs. You mentioned that the APIs are available as a patch now. In the interest of time, because we only have 3 minutes up to the hour, and we actually had the intention of giving you the chance to grab a cup of coffee or something, I suggest we move all further discussion to the Slack workspace. You can find the link to the join link to the Slack workspace in the chat. So just click on that, and it'll take you to the landing page. Slack will guide you through the registration, and then you can interact with lots of folks. I mean, we have lots of folks from all kinds of geographies in the Slack channel, also representing the local user groups. So if you want to interact with anyone in your geography, be it, if you have questions about local events, be it for conferences, be it for a joint beer at the pub, that's clearly something you can do via the workspace. You can directly interact with folks. And we have people on the Slack workspace from all kinds of geographies. And even if your geography is not among them, I'm pretty sure that there will be someone who can point you into the right direction. Now, with that, I would suggest that that Tim and Derek, who will be presenting next, start at least sharing their title screen so that we can get ready for that. We still have another 2 minutes, and apologies for running over. I hope everybody is set. I've seen you come in on the